we start getting into like the parent functions and the translations, which can also be called phase shifts, I just want to bring back to mind this idea of function notation. I always tell my students function notation, or f of x, is just a fancy way to write y. They mean the same thing. So this f of x means nothing mathematically. There's no operation here. It's not f times x. You don't have to do any addition, multiplication, or anything on the side if you have a number in place of x. Okay. So instead of writing the equation of a line, y equals 2x plus 3, we can write f of x equals 2x plus 3. So it's just replacing the y. I think there was a question on your summer packet quiz where they gave you some function, f of x, and they asked you to evaluate it for some value. So like, let's say I have f of 4. Notice 4 is in place of what value in function notation? It's replaced the x. So it just means on the other side where you see x, put 4. So f of 4 is equal to 8 plus 3, which is 11. And the reason why mathematicians have this function notation is, what's really nice about it is, like, if I had used this other version, y equals, I would say, well, I would have to tell you to evaluate it when x equals 4. And then you would just say y equals 11. But if I gave you a different one, x equals 0, you would say y equals 3. But they all look like y's. If I put the function notation there, f of 4 equals 11, you know y is 11 when x is 4. And then I would have like f of 0 equals 3. So you know y is 3 when x is 0. So it's giving you more information about the function. It's giving the x-coordinate and the y-coordinate together without having to write words. Okay. So what I want you to do, I'm going to give you a little bit of time here. Okay, these are going to be the parent functions. So I would write something down in your notebook that you're identifying this little section right here. These are going to be the parent functions that we'll be using in chapters 1 and 2. You don't have to necessarily write down this piece that's in italics because these are the directions of what you're going to be doing. I'm going to have you work with your pods, your groups, to make a table of values and then sort of sketch the graph or plot the points and graph each parent functions. I'm kind of giving you a hint here. Use the values x equals -2 to 2. If you were uncertain of what the shape would look like, you could always use more x's, right? You could add a -3 or 3 or go further out, -10 and 10. So when you make a table of values, you can choose whatever x's you want. But for these, you'll be okay if you go -2 to 2, and you'll get the gist of the graph. So we have 4 of them. I'm going to scroll up. The first 2 are going to be constant and linear functions. Linear is often sometimes referred to as the identity function. Okay. And then we also have absolute value and quadratic. Okay, so you're going to do 4 of them together with your groups. I'm going to give you about probably like 5-ish minutes. Okay, we'll kind of see how we're doing. So like write down the word constant. That's the type of function this is called. Its equation for the parent graph is f of x equals 1. And then you'll make a table of values. You have x. Remember, we're going from -2 to 2. And then I put it as f of x, which is really just y, right? So now, if I put in -2, what am I going to get out? One. What if I put in -1? Get out 1.
Constant.
Constant. Okay, so work with your groups and do all 4 of those families. While you're doing that, I'm going to just put books on the pods. You can just leave them in the middle of the pods and we'll address the books later, but that way check with your pod members, you agree on your table, and then when you graph it, what does your graph look like? I think you should probably be finishing up constant and on to linear if you're not already there. Go and graph them all so you know what their shapes are. There's your linear graph and table. Hopefully, as you were filling out the table, maybe you could recognize why that one is called the identity function. Whatever you put in for x is what you get out for y or f of x, right? So -2 yields -2, -1 yields -1. And then graph that and you'll get a slanted line. You got 2 more to go, absolute value and quadratic. If you need to, talk to your groups about what absolute value means.
On 2.
Let me ask you, what is absolute value?
Oh, this is one of those weird
Okay. Okay, and what if we put in a positive one? So I would maybe check your table because I disagree with your picture. And I would check how you plotted your points. Like I don't think -1 Does that make sense? Good job, Abby. Let's see. Remember, x's are left and right, and y's are up and down.
I love the actually. I got a slanted line. It's just a side of It's just
But
this.
that's not a function, AC. Oh, and
I know, that's what I was thinking, but like.
Which one's the absolute value? Your turn.
Let me ask this question. What does absolute value mean?
Math is like this one here. I can get one.
Okay, so look at your table for absolute value. You put in -2. What do you get? Yeah, okay. So 2 orders here. Yeah. I disagree with this one. Like, there's the one.
No, I switched. This
Oh,
this
this
one.
one's absolutely, this is like,
So
I make.
any imagine competitive six this one was. That's gonna be kind of.
Absolute value
Yes.
is
My kid is just
It's
different.
always, so whatever you put in,
This is a parabola.
Okay.
that's how I.
Yeah, the absolute value is a parabola. Functions and graphic, I think is the easiest to do math. For the most part.
Okay, if your absolute value does not look like a V,
You've done something.
let me know. I think you just have these, you have this right. You just plotted them differently. Remember, these go left and right, these go up and down.
Now be careful with the quadratic, so it won't also be a V.
Like this could be because you are making your coordinate plan, but I would argue like the points 0, 0, 1, 1, and then what else do you have? 2, 4, that those aren't actually on. So that you should use it.
Did I keep this right?
Yeah.
I did it wrong.
No, I thought you said, did you do it right? No.
For quadratic,
You did it right.
it's just a stretch.
Yes, so I would just be really careful. It could be because you're plotting your tick marks.
Yeah.
But like your points, 0, 0, 1, 1, and 2, 4, don't actually lie on a straight line. Like you can't connect them with a straight line like you have for absolute value. It should be more curved. Okay. How you doing, Stefan? Yeah, it looks good. Now, this last one, the quadratic, is probably the one, especially since you guys are like graphing, like you're making your own tick marks. You know, we're liable to human error here because if we space the x's differently than the y's, then it's not like a 1-to-1 ratio. So this one is a good one where like if you were unsure, you might add another x to your table. So like what if I put in 3 and then square it, I'll get out 9. Well, if I count 3 to the right and 9 up, I'm going way up there, and that would be true at -3 as well. So what you should find is you can't connect those with straight lines like you could for absolute value. So you're going to have to use curves. And I heard some groups talking about what shape is this? A parabola. Okay, so maybe write that down. Parabola. U-shaped. Absolute value is V-shaped. What's going to be the difference between linear functions and the constant function? I love what AC said. Linear will be diagonal. So it's a line, but it could be diagonal, or I sometimes say that it has a slant, okay, or like a slope, okay. And then constant is a line, but it's always horizontal. It does have slope, but its slope is 0. So that will always be true. Okay, so we're going to be studying these, what are called families of functions, and so it's important that we know the basic shapes of those families, because if you should have studied this back in Algebra 1, if it's an absolute value function, it will always be in the shape of a V. If it's a linear function, it will always be the shape of a line, right? So if it has that form with other numbers in it, then you know what shape it's going to be. Okay. So function families. Okay. Why are we calling them parent graphs? Because they're the parents to the family of functions. If we relate that to a family as we understand it with two biological parents, their children share DNA with those parents. So they have some of the characteristics. You might often hear, oh, you look just like your mom, or you look just like your dad. Families share key characteristics. That's true in the function families as well. So going off of what I was talking about on that last slide, graphs within a family will always share the same shape. So we now know all graphs or functions, if we see absolute value bars, they're going to be these. The parent function is the most basic. Okay? Pretty boring, nothing really interesting happening to it. It often sits or is like oriented at the origin, which is 0, 0. So notice like your U and your V have vertices at the origin. And then other functions are transformations. So we know if we have an equation of a line that isn't y equals x, let's say it's y equals 3x, it's going to look different, transformed version of the linear function. If you add extra numbers in, your function transforms. Now, in chapter 1, we're going to focus mainly on the linear function, so slanted lines, lines with slopes other than 0, and absolute values, so the V-shaped graph. And then in chapter 2, we'll be looking at quadratics. So just like a heads up on that. Okay, we're going to focus on those two. We might see the constant here and there, but we don't really like make a big study out of the constant function because it's a horizontal line. Let's not get too excited about it, right? Okay, so today we're going to talk just about translations. A translation is a type of transformation. So transform is how you change something, right? Think about transformers. They change. Later on in pre-calculus or algebra 3, you might hear translations referred to as phase shifts. So I'm just putting that word out there. I usually call it a translation. It's going to shift your graph horizontally or vertically. So in quick terms, today we're just talking about left, right, up, down. There is no change in the size, in the shape, so a V will still be a V, or the orientation. So that would be like if your V is opening up or your V is opening down, okay? Those things won't change. Okay, I'm going to pull over a Desmos graph. Folder. What kind of family or which function, parent function is this? Absolute value, because it's a V shape, so this is f of x equals x. I have some different functions, and the first one I'm going to do is y, or f of x equals the absolute value of x minus h. Okay, so I'm going to put in different numbers for h. Watch what happens if I put in positive numbers for h. What's happening to the graph? It's moving to the right. So when I put in positive numbers right here, like right now, it looks like h is 4.2. Okay. Then my graph is looking like x minus 4.2, or my function, x minus 4.2. And you guys are telling me it's going right 4.2. What do you suppose will happen if I do a negative number? So x minus negative 4.2 is going to go left. So if I put in the negative values, okay, I'll just move my slider. If I put in the negative values, so now you can see h is moving negative, then it goes to the right. But in the function, this is actually going to look like x plus 4.2. So plus goes to the left, minus goes to the right. Okay, I have another function where I'm going to take the absolute value, and I'm going to, instead of subtracting something on the inside, I'm going to be adding something on the outside. So if I put in positive values for my k, watch what happens to your graph. What are we seeing? It's going up, and if I put in negatives, it's going down. Okay. Do those translations sound familiar to you? Have you ever studied h and k before? Some people are nodding yes. Okay, awesome. So let's put those down into our notebook. These are the translations in function notation. So I kind of rewrote the linear and the absolute value function. So this one is linear, and this one, of course, is absolute value because it has the absolute value bars. And I put in the h and k. Now, tomorrow we'll be talking about the a's. So you might remember there was an a, h, and k. So there is more to transformations than just right, left, up, down. Notice that when you have an h, it goes with your x because h is moving you horizontally left and right, so it should be affecting the x value. So x and h are always in a set of grouping symbols. For the linear function, the grouping symbols in the end aren't necessary. You'll be able to combine the like terms h and k. Because like of the associative property up here. But for absolute values, you can't combine this h inside the absolute value bar and the k outside the absolute value bar. You'll have to leave those alone. If it looks like f of x minus h, then it's going right h units. If the function looks like f of x plus h, if it's got a plus number after x, then it's actually going left h units. And then we have a similar set of rules for the k's. F of x plus k is up. f of x minus k is down. Yes.
Could you go a little slower with the
Notice down here, the k is no longer inside the parentheses. Because if you're moving up and down, you're moving vertically. You won't be just affecting the x, you'll be affecting the y. And f of x is a fancy way to say y. So it's y plus k and y minus k to move up and down. Okay, so one other thing that I always kind of stress, and you'll hear me say this a lot, is to make sure you get the right transformation. H looks like the opposite of what you think it would be, right? Like normally right would be positive, but it's actually a subtract, a minus. And left would be negative, but it's actually plus. So I always say over and over again, H looks like the opposite. H looks like the opposite. K looks like what it is. Any questions so far? Okay, I think we just need to look at some examples of like what you'll be asked to do on your homework. We will graph absolute value functions that are shifted left, right, up, down, and our other transformations, but that's going to be on Thursday. Right now, you're just practicing writing equations. Okay. So here's an equation. Let f of x equal 3x minus 5. What type of function is that? Belongs to which family? Constant, linear, absolute value, quadratic. Linear. You might recognize that as mx plus b. We're going to write a new function g of x, whose graph is a translation 4 units up. Well, if you want to move up or down, you want to add 4 to x or y. Y, which is just a fancy way to write y is f of x. So we would be saying that g of x is our old function f of x plus 4. That's in just function notation. The new function g is the old function plus 4. And what's the old function? 3x minus 5 plus 4. Clean it up. That's 3x minus 1. Done. A second question, let's do this one. Let's translate this graph so that it's going 3 units to the right. So we're going to write a function h of x. How do you move functions to the right? Minus h from the x or y? From the x, which needs to be protected by a set of parentheses. If it's x, it's always got to be in a grouping symbol. So we could say that this is f of x minus 3. Okay. This version is what we call function notation. Don't let that scare you. It's just the function notation. It's the original function f shifted right 3. That's what that says. Well, f is 3x minus 5. But now in place of x, I want to put x minus 3. So this is going to be 3 times x minus 3 minus 5. Move it up for you. Remember, when you do a right-left, you have to put it in the grouping symbols. So now, if I want to clean this up, I have to distribute the 3. So I'll get 3x minus 9 minus 5. That's 3x minus 14. So that's my h of x. Here's the wrong version I would get a lot. H of x equals 3x minus 3 minus 5. X minus 8. Because there's no parentheses around this x minus 3, you're really doing this. This is the same as 3x minus 5, the original f of x, and you're subtracting 3. So that's like y minus 3, which would be down. Okay, so you have to be careful. If you're doing it with a right-left, you need a group of parentheses. We'll do a couple of quick absolute values. Okay, here's our absolute value function. Let f of x equals 2x minus 3 plus 1. And we want to write a function whose graph is a translation 2 units left. Okay, so think about in function notation how you make something go to the left. It should look like x plus that number. So g of x equals f of x plus 2. And then we just make that substitution. That's the absolute value of 2 times x plus 2 in parentheses minus 3 plus 1. So where the x is, because this is f of x, if you're doing f of x plus 2, you are substituting x plus 2 in for that x, replacing it. Clean up the inside there. That's 2x plus 4 minus 3. Combine like terms. G of x equals 2x plus 1 plus 1. Questions? Yes, Maddie.
So where is that? I'm just confused where you're getting that 2 plus 2 from the x. All the tables.
That's my h. Good question. Okay, I think last one is probably a vertical shift, so I'll let you try this one. Can you translate this function 1 unit down? I'm going to call it h of x. You can put any letter you want in front of, like, in place of f or f of x. If you want to use m of x for Maddie, you could do that. W of x for Will. Write a function h of x whose graph is a translation 1 unit down. You share your answer with your group members. See if you agree. Moving that 1 unit down. Okay, let's see. Going 1 unit down, you want to take your original function, f of x. Remember, f of x is a fancy way to write y. And if you want to move down, you want to subtract 1 from y. So plug in your f of x, which was the absolute value of 2x minus 3 plus 1. And then minus 1 from it. What happens to plus 1 minus 1? Gone. So h of x, sorry, I was calling this h of x, wasn't I? H of x is the absolute value of 2x minus 3. The minus 1 has nothing to do with the stuff inside the absolute value. That all has to do with things that are horizontal. So when you're moving it up and down, you're just doing it to the whole function, like at the very end of the function. So make sure you correct that in your notes if you guys had a different answer, so you can use that as examples for your homework tonight. Okay. You don't have to write down your homework assignment every day because I have something called a gold sheet, and I'm passing that out to you now. So if you look at the gold sheet, the first day tells you the same homework. You're welcome. So your homework tonight is page 16, numbers 3 through 10 and 37. Pretty reasonable, I'd say.